My name is Andrew Anampu from Moringa School. As we've talked about, we are a coding bootcamp. We teach people how to code. And today we'll just have a stripped down, back to basics approach to what in the world coding is. Um, I'm going to describe someone, and at the end of this description, I'll ask for your input. So this person wears a lot of hoodies, jeans, baggy sometimes, has no idea what formal shoes are, and has those glasses from the guy from Heroes. How many would say that this is a developer or someone who codes? Raise your hand if you feel that's true. Right. Um, that, in fact, is a true misconception about coding. And we're going to take a look at what that means today. In essence, coding is giving instructions to a computer to do something. In essence, you do need a laptop for compute, you give it instructions, and there's an output. Um, an example of this would be computer. My name is Andrew, and I'd love to see that on a web page. And as you can see, it returns to you, Andrew. And even from the syntax that's written on the slides that I have, you can see it's not so complex as in the movies. There are no green screens with ones and zeros raining down from heaven. It's quite simple. Anyone can learn how to code. Um, so here we have a small snippet of a program in a language called Python. We'll touch a bit more on languages. And I'm telling the computer, my name is Andrew, and store it in this bucket called a variable. And then once that bucket is saved, please return it back to me. So in essence, the computer is going to return the variable. When we talk about coding, we can't talk about coding without having the discussion of what programming languages are. Again, these are ways in which computers talk to each other. Just the same way we have English, Kiswahili, French, Spanish, German, and all other languages, computers understand different languages with different syntaxes. So, for example, our previous snippet was written in Python. And as you can see, we have things like Java, JavaScript, C++, and Scala. And we have more than 100 programming languages out there. Again, it's just a different way of giving instructions to the computer from our diagram above. Um, some would ask, why is this important? Why is it important for us to be giving instructions to computers for them to compute? And you can see the constructs of our daily life, from our mobile phone to traffic lights to connections to the internet, are built on such a base layer. They're built on a processor getting information in terms of languages, processing that information and having output. Or in some other instances, making sure that that output is input for another process. So once we have the languages that dictate how we talk to computers or processing powers, then we start to think of the large scale applications of this, right? We have web applications that are published on the internet. The infrastructure that the internet is built on is on the same principles, and we also have hardware principles for that. I love that there are a lot of lawyers in the room, because with such great power, there are a few things that we need to take into consideration, right? One is regulation of what people build, how they build it, and the data that they consume in that, right? We need to start thinking about how we can not necessarily control, but regulate, put some standards in place to make sure that people are building the right things, useful things, and impactful things. Now, I mentioned data. When you think of a programmer who's creating products for us, one byproduct of their output is data. they're creating a lot of data as we go. And this has also given birth to a new branch of computer science called data science, where we have people just getting some insights from that data. But we need to also think about what kind of data goes into these programs and what kind of data comes out of them. And finally, the biggest one is education on how we build and the products that we build, making sure that we're reaching the masses with, how to use these things, how to build them, how to maintain them, and what policies govern them. Obviously, we can't have the coding conversation without talking about the internet, right? On a scientific level, we have these computers that we're building, we're feeding in programs and getting data in from. Um, and the idea of the internet is that what if one computer could talk to another? And what if this group of computers could talk to other groups of computers without bound of location? And thus came a very massive network of computers all over the globe, and that's essentially what we call the internet. It's a very scientific thing if you choose to study computer science or try to understand the mechanics behind of it. But it's come a long way for us to just flip a switch and get connected to the internet and be able to post a tweet, read a Facebook post, read a WhatsApp message. But again, the internet is a very powerful tool that we are using to co-create, share, and also start to imagine a few things with coding that we can do. So in my short time, I hope I've demystified what coding is for you. Coders are not people who wear hoodies and live in very dark rooms and have green screens. Well, they were until we discovered Pinterest. Okay, but there are people who actually build and design a few aspects, if not majority aspects of our life. And I hope within these few short minutes, I was able to demystify for you exactly what coding is at a basic level. But if you have any more questions, I'm more than happy to answer your questions at the booth in the next room.